Hello everyone. Recently I just went for an interview in Arup, Malaysia and also Tiwali, Malaysia. And right now I would like to share what they asked me in that particular interview. They asked me a lot of technical and a lot of professional questions. But I would like to highlight some of them in my video. First, the HR, when I was waiting, the HR asked me to write a letter to client to extend the deadline, and they asked me to state the reasons and the new deadline. Because partly because there's a miscommunication between the clients and the engineers that went to represent you, and also the reasons that I stated is because we need to implement some of the new technologies, and amendment and time would be needed for making changes to the drawing, and also we propose that it can be done as soon as possible. And after that, the director actually interviewed me, and he asked me about internship I've done in Singapore. So I've done in SYT consultant. I mostly do the bus shelter for LTA, and you can see he asked me about what I've designed. I have to actually, luckily I've just revised all what I've done, and basically I explained about three cases: the load 1, load 2, and load 3, where you have the maximum 1.4 and 1.6. On the load case 2 is 1.1 plus 1.2. Sorry, 1.2 plus 1.2. And also the effective length of column is 1.0, because you can see there's one end fixed, one end free. So the wind load is blowing horizontally. And the bending moment, he asked me to draw the bending moment for the diagram, but I was actually have no clue how to draw it, because I was using StepPro. But nevertheless, they asked me a question afterward to actually gauge my understanding of the structure's behavior. And you can see this is actually the columns, and they transfer the load. This is the roof. They transfer the load to the beam, and then the beam will transfer the column to the column. The beam will transfer the load to the column, as shown as above. In Tiwali, they asked me more or less about the same thing, but I would like to mention about is he asked me about notional load, and notional load is something that is quite new, and I guess if you guys really need to know, you have to go and find out about it. So now is the technical question that they asked me. This is very important, because I think this is the part where they ask whether you know what you're doing for so long in engineering. So right now I will draw for you. This is UDL. I'll draw for you the bending moment diagram. So this is the bending moment diagram for this, and for this, the bending moment diagram is this. And for this, you actually have sagging and hogging in the middle, then sagging again. Okay, for this is the tricky part, because it's linked to my bus stop. So you imagine this as a cantilever and apply load here, so there will be a movement like this. I actually get it wrong by drawing some kind of deflection, but luckily he gave me a second chance and explained to me, and I managed to draw it. This is a question that I don't quite answer it well, and he teach me that actually from here you have this bending moment, and from here to here you have the flat moment. So this is the bending moment. And for Tiwali, the director is a she actually asked me a tougher and more technical questions. I need more time to think about it and regroup. Nevertheless, this is the loading that he showed me. So I'll just draw the shear force diagram. Go to 0, then there's a force here, and come down, then go to 0 again. For this bending moment diagram, because it's point load, so you have triangle, but it goes up, and you have a curve down nicely up to the 0. And this is the frame. That's quite hard to draw actually for me. And I wish to impart this kind of knowledge to you too. There's a force pulling at the side, so you can know this is fixed, this is fixed, this is fixed, this is fixed. They are all fixed. So when the force is pushing like this, you have a moment here, and because it's fixed, there's a moment here. This applies to both sides, and on top of here also you have a bending moment. Okay, so it should be triangular.